NASA popular, for its notable disclosures has as of late revealed that this new planet isn't just enamoring a direct result of its size, what's more region, yet also because it shows lights that radiate an impression of being fake. Are we practically uncovering insider realities that could change our appreciation of the universe? Could this disclosure mean there is life on other planets? Oblige us as we explore NASA's fascinating revelations and cover the truth about these remarkable lights. In 2007, NASA shipped off the Sunrise rocket with a mission to research likely the most entrancing articles in our planetary bunch. Daybreak was astoundingly outfitted with 3-molecule engines, allowing it to embrace an extraordinary trip. Sunrise's outing started with a 14-month investigation of Vesta, the second biggest space rock in the belt. During this time, Daybreak sent back unmistakable pictures and data, uncovering Vesta's intricate surface and different land narratives directly following completing its main goal at Vesta. Daybreak set out on the second and perhaps most intriguing piece of its endeavor, a definite examination of the smaller person planet Ceres on account of its molecule engines. Sunrise had the choice to leave Vesta's circle and decided to show up at Ceres, an achievement that conventional compound drive would have found. Testing these engines gave a steady, sensitive push, allowing first light to travel enormous distances capably and go into a steady circle around Ceres. Viewed as in 1801 by Italian cosmologist JPI, Pi Ceres is the biggest item in the space rock belt. Among Mars and Jupiter for quite a while, it was seen as the tiniest, smaller planet in our close by planetary gathering, until its renaming in 2006 with a expansiveness of around 950 kilometers. Ceres is the biggest and most gigantic body in the space rock belt, and quite possibly of the most spellbinding because of its fascinating credits. As Daybreak advanced toward Ceres, analysts energetically expected the principal nitty-gritty photos of this bewildering world they saw as brilliant spots dispersed across its surface, most remarkably in an enormous pit presently known as a cook. These splendid spots touched off speedy interest and hypothesis inside laid out scientists beforehand. Daybreak's main goal, the best picture we had of Ceres, was a fluffy low-goal picture taken by the Hubble Space Telescope. Scientists knew essentially nothing about this bantam planet, and the plausibility of finally getting a close-by view was energizing. What secrets would Ceres uncover? What new disclosures anticipated the mission promised to work on our cognizance of the planetary gatherings, improvement, and the job of water in forming planetary bodies? The splendid spots on Ceres are not normal for anything seen on various space rocks. They appear to be made from exceptionally intelligent material, possibly salts abandoned by sublimated water. This seeing implied to the opportunity of cryovolcanism on Ceres, an association where volatiles transmit with water or briny liquid rather than fluid stone. Anyway, what definitively are these peculiar lights, and what do they uncover about the idea of Ceres? Might they at some point be verification of non-stop land activity, or something essentially more interesting? Ceres stands apart from other great bodies in the space rock belt because of its size, mass, extraordinary arrangement, and potential for water and ice. Not at all like average rough space rock. Ceres has a synthesis more similar to a comet, recommending it holds more privileged insights about the early sun-powered framework than we at any point imagined. Following 2 years on the manner in which the Daybreak rocket at long last started its way to deal with Ceres in mid-2015, this second denoted a colossal accomplishment in the mission as first light, ready to convey humankind's most noteworthy close-up points of view on the biggest article in the space rock belt. As sunrise drew nearer, the photos of Ceres created dynamically definite contribution brief, takes a gander at a world that had beforehand been canvassed in secret. The first pictures revealed a surface spotted with cavities illustrative of a long history of effects. Anyway, it wasn't essentially the cavities that got the eye of scientists and space fans the same. Among these components were the perplexing, splendid spots that firmly stood out against the more dark, rough scene. As the photos continued to deal with in gold standard, specialists murmured with hypotheses about the idea of these splendid spots. Were they ice patches reflecting daylight, or could they be something essentially seriously entrancing? Theories went from mineral stores to expected signs of cryovolcanic activity. Unquestionably closer assessment revealed that the most marvelous spot was not a lone substance, but rather, all things being equal, a gathering of a couple of indisputable spots. This revelation just developed the secret and the hypothesis that these were stores of salts abandoned by sublimating water. Acquired balance. This would propose that Ceres had or still has some type of geographical movement equipped for bringing water or briny liquids to the surface, where they promptly scatter, leaving splendid intelligent form ups. These disclosures tested existing thoughts about Ceres, depicting a more remarkable, furthermore complex world than already envisioned. The presence of such highlights insinuated the possibility of subsurface water or briny pockets, which could have huge ramifications for how we could decipher the potential forever in our planetary group. Yet what makes Ceres novel from different planets? Ceres is a fascinating planet, frequently depicted as a frosty world with a rough yet penetrable surface dissimilar to most space rocks in the belt, which are chiefly made out of rocks and metal. Ceres stands out because of its novel plan. Its surface is a blend of water, ice, and hydrated minerals, counting muds and carbonates, which give it a particular less thick construction. Contrasted with its neighbors, this creation proposes that Ceres has a huge measure of water. The surface layer is rough yet penetrable with ice. What's more, different volatiles caught inside this frigid trademark is more suggestive of a comet than a common space rock, demonstrating a set of experiences that could include a blend of rough and frosty materials. Digging more profound underneath its surface, Ceres uncovers a lot additional fascinating parts of its structure. The Bantam planet is accepted to have a separated inside, including a sloppy mantle and a center. The mantle is believed to be rich in water ice, representing generally 50% of Ceres' complete volume. This mantle, a mix of rock and saline arrangement, encompasses a center that could be made from denser material, maybe silicates. The presence of such a lot of water ice recommends that Ceres could have once held on to fluid water, specific in the event that its center was warmed by radioactive rot. From the get-go in its set of experiences, this interior structure puts Ceres aside from its space rock neighbors and furthermore raises fascinating inquiries regarding its true capacity for land action and the job of water in its advancement. Anyway, that is not all. The revelation of alkali muds on Ceres infers that the Bantam planet may have framed in a colder piece of the planetary group and relocated internal. The presence of alkali can bring down the edge of freezing over of water, supporting the presence of subsurface brings these bits of knowledge into Ceres' creation and history, not just improve our comprehension of this interesting midget planet, yet additionally give important insights about the cycles that administer the arrangement and advancement of frigid bodies all through the nearby planet group. Cryovolcanism is an enamoring and, to some degree, dark geographical interaction, particularly when stood out from the more recognizable volcanic movement we see on Earth, not at all like conventional volcanoes that discharge fluid. Stone cryovolcanoes too known as ice volcanoes, radiate volatiles. For example, water-smelling salts or methane. These substances can exist as fluids or gases. In the very cool circumstances where cryo-volcanoes are found on Ceres, the cryovolcano works by permitting water, stacked with broke-down salts, to come to the surface. When this pungent water interfaces with the vacuum of room, it quickly rents, changing straightforwardly from a strong, or on the other hand, fluid state to gas. This interaction abandons splendid intelligent salt. Stores, the most well-known of these splendid spots, is situated in a hole named AR, otherwise called Spot 5. This district has procured critical consideration because of its high reflectivity and periodic fogs. Seen by the first light shuttle, these fogs are accepted to be brought about by the sublimation of water, which recommends that cryovolcanic movement may as yet be progressing or has happened generally. As of late, notwithstanding, Spot 5 Ceres has a few other splendid spots, each with its own special qualities. These spots are not restricted to a solitary district, however, are scattered across the smaller planet surface appearance. That cryovolcanism may be a boundless peculiarity on Ceres. The presence of these brilliant spots features the novel nature of Ceres and raises huge inquiries concerning the potential forever. In our planetary group, the dynamic nature of Ceres challenges stuck presumptions that it was a geographically dead world. As the sunrise space apparatus gave more definite pictures of Ceres, an overflow of surface highlights started to arise. The external layer of Ceres is specked with an assortment of cavities, each recounting an account of the Bantam planet's set of experiences. A few pits are generally shallow and dissolved, demonstrating an old surface that has been oppressed to different effects north of billions of years. Others are all the more all-around protected, with sharp edges and profound bowls, recommending later effects. Strangely, the quantity of pits on Ceres is not exactly at first guessed. This error indicates land processes that might be re-establishing the surface and eradicating proof of more seasoned influences. One theory is that Ceres' frosty synthesis permits for a type of cryovolcanic re-emerging, where subsurface materials irregularly well up and cover old highlights. This progressing geographical movement recommends that Ceres isn't a static world, however, one that has been and possibly still is effectively developing. Extra proof of topographical movement on Ceres comes from the perception of breaks, grooves, and box-like designs on its surface. These highlights demonstrate that the outside layer of Ceres has encountered huge stress and distortion. A portion of the breaks show up, generally youthful, perhaps 200 or 300 million years of age. It is still to recommend that the outside layer dynamic, the scores and boxes on Ceres, probable framed as the hull was extended, also pulled separated, while edges of mountains and pressure highlights show regions where the external layer was pushed. Together, these differentiating highlights offer a brief look into the complex processes that have formed Ceres over time. The presence of a huge vault-molded mountain in one of the pits proposes the chance of inward strain or upwelling of materials, perhaps related to cryovolcanism. This component, alongside the broad organization of breaks and miseries, focuses to a functioning and developing surface. The daybreak missions perceptions have likewise uncovered fascinating surface arrangements past the splendid spots and intelligent salts. NASA's information has uncovered a scope of surface materials that are basic for grasping Ceres' topographical history. For instance, specific districts on Ceres show a dull, fine-grained material that stands apart forcefully from the more splendid salt stores. This more obscure material is accepted to be a sort of carbon-rich substance, perhaps natural, which adds one more layer of intricacy to Ceres. creation and proposes potential for prebiotic science, the collaboration between these materials and the frosty surface might assume a part in the synthetic processes happening on Ceres in expansion. The discovery of natural intensifies on Ceres has ignited huge interest in astrobiology. Natural atoms, which are the structure blocks of life as far as we might be concerned, have been found as carbon-rich mixtures. These revelations are especially astonishing, since they recommend that Ceres would be able have conditions appropriate for the development of more mind-boggling natural atoms. The presence of these intensifies opens up conceivable outcomes with respect to potential forever, or at least the structure blocks for life being present on this Bantam planet. Another remarkable component is the immense number of strange vault-molded structures on Ceres. These vaults, some arriving at levels of up to 6 kilometers, are accepted to be the consequence of subsurface cycles pushing up material through the covering. Their shapes and sizes propose that they may have framed from cryovolcanic movement.